Hello everyone, welcome, good morning. Gonna be doing a presentation on supply chain optimization, a robust supply that minimizes cost. The idea here is to make a supply that is able to cover uncertainty on our demand. That's why it needs to be robust. What we develop is a decision support system for stock management that we've used that using the FICO Xpress Insight platform. We're gonna see more into detail on everything here in the screen in a little bit. First off, my name is Fernando Piqueras. I'm an operations research developer at the City for AI. Here on the screen, you have some contact information. You have our webpage as well as our emails. You can shoot any questions or doubts. We'll gladly address those. As for us, well, I've been working at the City for like 2 years. Here at the City for AI, we create tailored solutions based on operations research techniques, just to cover our customer needs. I've been involved in many multiple projects, mostly in retail, transport, and logistics sectors. So we've worked in collaboration with FICO. FICO is the world-leading provider of analytics software solutions and services. It just transforms the way organizations understand their customers, and we're focused on optimization and business processes around them. So some key FICO takeaways that we're going to see today, both value to business and then how it scales rapidly and the quick adoption into the business, into the projects. So first off, the value is going to see that we're going to be able to react to change with more agility. I hope that the demo that we're going to do at the end of the presentation will cover this. The idea is to deploy the best champion strategy with confidence. Another key takeaway from FICO is how the platform is going to accelerate the realization of business objectives. We're going to objectivize our these business concepts, and then we're going to accelerate towards like meeting those. In terms of scalability and adoption, well, first off, to start, the application we're going to see today has been developed from scratch without any prior knowledge, using the FICO platform. We've developed that within 3 weeks. So I think it's pretty telling. We have these key takeaways. We're going to be able to visualize possible multiple scenarios for our business outcomes. I think this is a very key important part we're going to see at the end, having multiple scenarios. Also enables collaborations between analysts and users in business terms. The application is made for both users and analysts. And then we're going to see less dependence on other IT. This is the outline of today's presentation. First off, we're going to start with some context, an introduction and definition problem. Exactly what our problem needs. What is exactly what we're addressing today. Afterwards, we're going to go more into detail about the problem statement, the considerations we've taken on our project, and finally, our MILP solution, how we've formulated our MILP problem. Once we have all the ideas clear about what the problem is about, this is stock optimization problem. We're gonna go into the methods and technology used on our application. We're gonna go into the architecture of FICO Xpress optimization that we've used on our application, and finally we're gonna do a live demo of the application that we've developed. Okay. So to start with the context, the problem is going to be set on a supply chain, right? Let us assume a supply chain composed by first a set of customers. Each period, these customers are going to demand an uncertain quantity of each product, right? The key concept is that the quantity is uncertain at the beginning. In order to meet the customer demand, we need warehouses that are going to be able to store the products. And on top of that, there's another layer of set of suppliers that will supply these products to the warehouses. This would be a normal supply chain. So our problem definition. Well, the first is that you have a few objectives. The most important objective to meet is that we're going to be able to maximize this demand fulfillment. We want to be able to meet as many demands as we can. This is our key objective, the most important one. But as well, we have other objectives to meet along the way, such as we want to minimize the stocking cost at warehouses. in order to supply this uncertain demand, we're gonna have to stock products in our warehouses. We're gonna minimize the cost of those, as well as we wanna minimize the distribution cost, both for the orders to suppliers and as well to the deliveries to the customers. The decisions that we're gonna make is, well, I've already introduced them. We're gonna have to make a decision on the orders to suppliers, and also which from our warehouses, from which of our warehouses we're gonna deliver to which customers. The key components that we have to consider on these decisions is that, well, you have to address when are these decisions going to be made, how much of each product, what type of product, and as well have to deal with the from where to where schematics. We're gonna model a project on with considering geographical distribution. We have to consider which ones are the shortest distances for all these deliveries. Okay, our problem statement. These are the considerations that we take in when modeling the project, the problem. So these are the indexes that I have, right? We have a set of periods, for instance, weeks. We have used a set of products, suppliers, warehouses, and customers. These are the data we're gonna see on our modeling. So first off, our considerations for suppliers. I've considered that when making orders to suppliers, there's gonna be a minimum and a maximum quantity that you can order at once. As well as on our warehouses, we can have a maximum storage capacity that we cannot store more than that on our warehouses. And then all the products that are being stocked, there's going to be a unitary storage cost for those products. Considering our customers, we can have an expected demand. Obviously, it's not final, but it's sort of like a forecasted, more into detail later. And then we have an undelivered cost, a penalty for not being able to meet the demand. For as well as our considerations in the actual orders to the suppliers, we have a fixed cost per order, which makes sense, and then as well the variable cost component, the cost per unit order. We also have to consider a lead time, the time that it takes for the product for the order from the supplier to arrive at the warehouse, and all these considerations have obviously dependent on the distance between the supplier and the warehouse. On the other side, for our deliveries to customers, we have pretty much very similar set of considerations. We have fixed cost per delivery. I have a unitary cost per delivery. You have both the fixed and the variable costs of those deliveries, as well as, and again, another delivery time. And all of this is based also, again, in between the distance from the warehouse to the customer. These are all the considerations that we're going to see, and we have to model all of this into our problem. So we've proposed a MILP model to solve the previously explained problem. So we're going to start with our initial inputs, our data. We're going to have a demand forecast. A demand forecast is going to tell us warehouses how much of each product they need. It's going to abstract the concept of customers. We're not going to be able to see the demands at that point. We're just going to have a forecast. And with the forecast, we're going to do Monte Carlo simulations to simulate what would possible demands for customers look like. So we're going to have to take this forecast model as our input together with the problem data. This problem data will the geographical distribution, or where everything is situated, as well as these fixed and variable costs that we've introduced. This will be our inputs for the model. We're going to feed this into the MILP. I'm going to explain in the next slides how this MILP is composed of, but just to introduce, we're going to divide this into two different stages. And then what we're going to obtain out of this MILP, out of this black box of a MILP, it's going to be our movements in the warehouses, as we explained before, these decisions that we're taking. So going more into detail on each part, first off, for the first stage of the MILP, we're going to be working with this decision variable, the order variable. This is going to be the quantity order by a specific warehouse of a product P to a supplier in a period of time. So again, the input data at this part is this demand forecast that we talked about. We're going to fit this into the MILP stage, and we're going to obtain this decision variable. So the key concept is that at the beginning, on our first stage, we do not know our exact demand, so we cannot plan around that. However, we're going to use this forecast to create our set of orders that we're going to make. The idea is that we have to order in advance at this first stage, and then on the second stage, it's when we're going to use these orders to supply our customers. So in this second stage of the problem, we're going to work with obtaining this second decision variable, the shipment one. This time for a specific period, the variable is gonna say how much quantity is being shipped from a warehouse of a specific product to a customer. So again, we have this output from phase one that was the order decision variable. We're gonna now have it as an input for the second stage, and we're gonna put it together with the actual real demand, the expected demand. After we made our orders in advance, now we actually do know what our demands are going to be like, and we have to supply these demands, right? So we're going to fit this into our middle stage, and we're going to obtain the actual real shipments on our model. So we look at it together, but a holistic point of view, you have these two decision variables, the order and the shipments. You're going to fit an expected demand together with the pollen data, and we're going to obtain, in general, these two decisions variables. So the methods and technology. We've developed an application. The application is using the FICO Xpress Suite software. So underlying all of the application to solve this MILP, we have an optimization software. If you use the FICO Xpress optimization, this is the software that's going to be solving and optimizing the MILP model that we just explained. On top of it, this application is going to allow the users to manage the data, such as our suppliers, our warehouses, and our customers. On top of that, the user is going to be able to interact with the application through a user interface. This is being done through the FICO Xpress Insight software. The demo that we're going to see today is going to be on this platform, on the FICO Xpress Insight platform. And then our data is going to be hosted on the server data, on the Insight data server. This is a look of how our application is going to look like. Now we're going to use a live demo. We're going to use a demonstration of how is our day-to-day operations with this application, the solution that we've proposed. So for our demo, we're going to have 3 different stages from use demonstration. First of all, we're going to look at the first stage, how we dealt with this robust stock. After we've done this robust stock, we're going to work into how the supply chain is being addressed. And finally, we're going to see some results analysis. So without any more further ado, let's jump into the application. We are already logged in to the server hosted on FICO Xpress Insight. This is what you would see when you log in at first. We have the name of the application at the top, and we already selected the app, right? This right here, this bar is the scenario manager. More into that later, but what we would see at first is these different tabs that they all express different views. The views are obviously what we see on screen. So if we click on this menu bar, we see the view navigator that contains all the views of our application. We have a set of views as inputs, with the different inputs that we consider for our problem. We got a set of views for the outputs, as well as a set of views for the analysis. So we're now in the input section, and these are our 4 different input tabs. The one that we're seeing right now on the screen is the forecast and simulations view. In here, we're going to see our demand forecasting, and as well as the simulations, the Monte Carlo simulations for the demand based on this forecast. We have another view for the warehouse configuration. In here, we have the rest of the input data for our problem related to warehouses and suppliers, and we're going to be able to configure some parameter settings for the execution of our model. We have a demand view that we're not going to see it at this first stage, but this one is for the second stage of the problem. This is where we would actually introduce the real demand, the final demand that we have to supply. And we also have a map view where we're going to be able to see these inputs in a map view. So what we're seeing on the screen, we're seeing actual data. It's already loaded, right? So we've done so by using the scenario manager at the top. If we click on the scenario manager, these are all the different scenarios. We can consider scenarios as data sets. So we already have one already scenario loaded in this column on the shelf. This one is ticked. The shelf is the scenarios that we already have here. added to them. So if we want to add more scenarios to ourselves, then we just click on those and we're gonna press the add button, and we see that they're added here to ourselves. So for today's demo, we have our company plan already made. We have different scenarios for the data at every single stage. So we're gonna add all 3 of our company's plan to ourselves. If we close the scenario manager, the data that we're seeing on screen on our views is the one with the scenario that is farther on the left. We can move this around. We're gonna do that later to change scenarios, but the one that we're seeing the data, it's from this one, the left outermost. So we actually have in this view, we have first our forecast table. The forecast table, again, for a warehouse, it will tell us how much quantity is forecasted to be needed for a specific product at that specific period. This will be our starting base on what we're gonna work with. So this is obviously pretty extensive. You can only see some of the period 1, but you can obviously move around the table with these arrows. We can see here some of the period 2 as well. So if we take a look at the quantity, we're gonna see later how this data is loaded, but we know that we can actually modify this easily if we're gonna change around and play with our forecast to see what like hypothetical scenarios where I might have more or less forecast. How would I deal with that? You have here some few buttons to modify the forecast on the table. We can add a value here, a percentual value like 20%, and we can press the button, for instance, to increase the forecast. We're gonna see that when this action is being executed by clicking it, our forecast has gone up by 20%. The table is really good to have all the information that we need. Basically, I import from a spreadsheet, right? But for us humans, it's way easier to see these values here on our forecast graph. So in this forecast graph, we're going to have the same information in the table. However, we're going to be able to see it, again, graphically. So our graph has the periods on our x-axis. We're going to see all the different periods. As well on the y-axis, we're going to see the quantity for each product. And the way we have each product here addressed, we have here a legend of the different product units. Right? We have SKU from 1 to 6. And we can see the different products by hovering over the data. If we have the mouse over 1, we can see the different values for each individual color-coded by this legend, right? So, for instance, on this graph, we're able to be telling more detailed info on how is our forecast situation. We can easily see that our most busier periods are going to be period 4, 5, and 6, being 5 our highest demand period based on this forecast, obviously. Whereas period 1 and period 8 are going to be less intensive compared to the other ones. This is something that we can easily see and understand based on looking at the graph. Then again, from this forecast, we've commented that we've made several scenarios. Okay, so we have here 5 different simulations. Okay, and these simulations are just Monte Carlo. We're gonna create fake demands for our customers based on this simulation. So we click on one, they're gonna see the demand table populated. You can see how our simulations look like for each of the simulations here on this drop down. So on this demand table, we have the demand ID, the expected quantity for a specific period, for a customer, and for a type of product. Obviously, we have the idea simulation, and we also have as well the penalty, the cost for not being able to deliver this demand that we currently set to the same for all of them, but it would allow to give different priorities to demands. Again, this information has like 26 pages of data. However, we can easily address this demand. We can see and have a better look into it using this graph. Again, we have all the same information on the table, but we can see the data here more clear. You can understand that it has the same tendency as before for the forecast, where period 5 was the busiest. However, it's not as, it's obviously random, so the data is skewed, subjected to randomness, obviously. This would be how we would view some data in the FICO Xpress Insight application. We've seen how the inputs for our forecast and simulations in our application. We're going to go now into the next view for the warehouse configuration. Well, again, in this step, the first buttons we're going to see the load button. Obviously, we are seeing all the data populated on our scenarios up here. However, this is being done by loading the data first off. So how this is being done, if you go to the top right here to the gear for the settings for the actions, if you click on it, you're going to see here app attachments. If we click on app attachments, we're going to see a set of CSV files that we've uploaded here. And these ones have the information that we see on the table. So a user may upload their own files here. And then when clicking the load button, all of this data will be loaded into the tables. This button for run simulations is going to execute the first stage of the model. We're going to see that later when we actually execute the model. However, looking into what we have here, you have the rest of the tables for our input data. We have a warehouse table. We're going to see all of our different warehouses. We currently have 3 warehouses. We see the stocking cost as well as the maximum capacity of storage for units. We can as well set up a warehouse to be unavailable for the execution of the model. As in, we're going to see that later in an alternate scenario, what would happen if we just do not count with that warehouse. The data here is able to be edited. We can mark it or mark it as unavailable, as well as we could edit these values, these numeric values. We could probably increase the maximum stock capacity. We're going to set it back to where it was. This is making reference to the warehouse configuration idea of this view. Next up, we have the suppliers table. We have our set of suppliers. Again, we have a fixed delivery cost for making these orders, as well as we could also set the suppliers as being unavailable for the model execution. As well as we have the rest of the data, we have a different set of periods, right? We have to consider these ones, for instance, as weeks. They're just like example periods. Then we have our customer table with the latitude and longitude of where these customers are located, as well as our different product table. In order to be able to see more into detail on how my geographical distribution of my customers, my warehouses and suppliers, we're going to go on to the next view. Again, we're going to jump over this next view, the demand view. We're going to see that on the second phase for the real demand. We're going to go into the last view of the inputs to the map view. And when we go into this map view, we're going to see in here, we're going to see this like blue, brown and red. This is going to be our different warehouses, okay? Whereas our green triangles are going to be our suppliers. If we can hover over this, it's going to tell us information from our suppliers. Finally, we have the different dots. These are our customers, our set of customers. So here in this map view, we can have a better look at what our data set looks like on the map view. So this has been all part of the inputs. Now what we do is we could actually run the simulations to run the first stage of the model. We've already done so, and we have the data already run on this other scenario on the second stage. We've done so just for brevity to avoid the waiting time. So we're gonna move the scenario by dragging it to the first position, and when we do so, it's gonna change the data. The scenario is mostly the same, except it's already been run. So if we click to the views and we go to the outputs view, in this outputs view, we're gonna be focusing on these orders and deliveries. On this view, we're gonna see both the orders and deliveries. Our most important identifier to see at this point is that this table of orders has been populated. These will be the orders that we're gonna obtain from this first stage. We had this uncertain demand, and we wanted to take decisions on which of our orders are gonna be to populate our warehouses with stock. We obviously use the simulations to be able to simulate later deliveries, to have a full product, but here we can see on the table that we have, well, for each period, we have the different suppliers that are making supplies of different products, and we have here the quantity column and to which warehouse they're being delivered. Here at the bottom, we would have a different drop-down menu to check all the different simulations, and then we have the custom deliveries for the demands on the simulations. This is not a real output of the problem, because we're gonna use the second stage to obtain the real deliveries. However, it's here to evaluate how it might have reacted to different simulations if we wish to see that. So this has been the first stage of our live demo. We've looked into the demand forecast, how we handle these data inputs, how is the forecast being treated, as well as the simulations being done from the forecast. We've looked also into the work configurations view. We were able to model a little bit how the problem data is going to be, as well as take a look at the rest of the inputs. We've seen this problem data in the map view, where we could locate every single component geographically, as well as after doing the first execution, we were able to see the orders output. This was the key takeaway from the first stage. Now we're going to go into the second stage of the supply chain. So once we already have the orders, right, we're going to go back into the inputs, and I'm going to go to this view that we skipped, to the demand view. We're going to upload, again through the load, a set of data with the final demand, and this is the page where we would work with the real demand. So first off, we have two different buttons for execution modes. We have a first button for the complete run. If you wanted to just execute it faster, this button would execute both the first and the second stage, provided we have all the data already added to it, both the forecast and the real demand. And then as well, we also have a button to run the final demand. This would run the second stage of the execution, the one that we're currently at. So you have, again, a demand table. This demand table has the demand for the final simulation, the actual real data. So these are the real expected quantities that we need. And then again, we can take a look at this data in a graph here to be able to see a ISO breakdown of the different products. The way we've obtained this data, we did five Monte Carlo simulations for our to obtain our first 5 simulations. However, we've done a 6th one, and this 6th one is not being used for the first stage, but it's now being added to the model to work with it now. So what we would do now is we would run the final demand button to execute the second stage of the problem. We've already done so, and we have that data on this last scenario on the company's plan complete. So we're gonna drag this scenario to the beginning, and then we're gonna explore different data. So if you go to orders and deliveries, back at here, we have now the final simulation selected, and we're gonna be able to see all the custom deliveries for this, for all these customer deliveries for this final simulation. Again, this is very extensive to see on the table. There's a lot of data because of our demo data. However, we can see this. We're gonna skip for a little while the stock view. We're gonna go into the map view, and we can see all these deliveries being done over here. So we had, again, our 3 different warehouses, right? If we click on those, and if we click on a warehouse, you can see all the different shipments that we've made. You can see this through these lines here on the map. If you zoom on it, you can see that from warehouse 3, this one, we're supplying to a lot of customers, as well as we're also supplying a few others from like warehouse 2. This is an interactable view where we can see our data that we had on our table. We can see our orders here from the suppliers, and we can see also the deliveries from the warehouses. A quick easy view to understand all the information that we had on the table, the output of our solution. If we go back to the stock view, this is the other second output that we're gonna have. In this view, we're gonna be able to see the stock levels for each warehouse for the different simulations. So we're gonna pick warehouse 3 here. I'm gonna select the final simulation, and what we're gonna see, we have a table. On this table, we have as rows the different products, right? We have the SQ126, as well as a final row with the all. This is the sum of all the rest. And we have per columns, you're gonna have the different periods, the quantity of the stock levels for each different period. It's from period 0 to period 8, and then the actual quantity value in the table on that matrix. It's easier to digest all this information if you have a look at it on the graph, right? This is the graph that we're gonna have the different periods and the quantity for each product. So you're gonna see the stock per period and product. However, we've added this SQ all, this summatory of all the products, that is altering our different edges. Like it's mostly, we can in this graph you can barely see the other products because the sum is quite higher than all the others. So we're gonna go back to this legend view. I'm gonna click on the SQ all so we can disable it from being viewed on the graph. And now we can actually have a better view of the individual products per period. So we see that we stock early on these early periods, right? Having these like middle periods, specifically period 4, like our busiest, fullest, and then for the last periods we were like released all the stock to handle all this supply. This would be how we view the different stock levels for our warehouses on our current solution. So now that we've seen all the outputs for the data, the most sensible part is to analyze how this solution was. So we're gonna go into our views, we're gonna go into analysis, and we're gonna go into the KPIs view. Okay, the scenarios one we'll see it later, but for now we're gonna work on the KPIs view. So we already have selected a simulation in this view. You're gonna see the KPIs for the current selected simulation. We're gonna use the real data, the final one, and what we're gonna see in here are the different measurements, our key performance indicators that we have decided to show on this application. These are the data that we think that it's gonna be able to tell how good the solution was in comparison. These are the two KPIs that we've decided to show. These obviously would be adapted to our customer needs, depending on the actual context of the problem, and this can be easily customized to any customer. So we have two different ones. We have one for cost and the other one for the service level agreement. So looking at the cost, we have first a table for the total costs. We have for the simulation selected the order cost. This is for the orders from suppliers to warehouses. The shipment cost. This is the cost from the deliveries from warehouses to customers, as well as the stocking cost. This is the cost for having the units being stocked in the warehouse. And then you have a final row with the total cost, the sum of all the costs. We can see these different stocking and distribution costs on this graph right here. It's a stacked bars graph. We can have a different color code for all the different costs, and if we hover over each of the periods that we have as our x-axis, we can see the different breakdown of this cost. Where we mostly on our solution, we have a lot of different shipments, which are the busiest part, or the ones with higher cost in general. We also have this next table where we have a breakdown of the cost per period. We have both for a selected simulation and for all different periods. We have the stocking cost, right? The cost in warehouses, as well as the distribution cost. This distribution cost is the sum of both the orders and the shipments. This would be our first KPI, the cost of the current solution. As our second KPI, we have the service level agreements. Based on our demands, how many are we able to meet and how many are we not able to meet. So we have an SLA table, right, for our current simulation, and for different periods, you're going to have the KO demands, the demands that we've not been able to meet, as well as the number of demands, the total ones, and then the OK demands, the demands that we've been able to meet. We can see this information in both of these graphs. First of all, a pie chart where we have both the OK and the KO ones, and we can see how many we've able to meet compared to how many we've not been able to meet. And then we can check this data per period, where we can see in blue our total demands, and then in yellow the ones that we've not been able to meet, and in green the ones that we've been able to meet. So we've used this data that has a few demands in period 1. We had to consider that it takes one period to order, another period to deliver. So we purposely added demands on period 1 that we were not able to meet because we didn't have initial stock levels. We didn't define this. This is done in purpose so we can show how not meeting demands would look like on our demo. However, our 3 set of warehouses is capable enough to see to handle all the rest of the demands for the next different periods. So in this second stage of the demo, working with the supply chain, we've seen the last input view for the expected demand, the actual real demand for our problem. We've been able to see the delivery data, over a table with the different deliveries for this expected demand, as well as we were able to see warehouse per warehouse the different stock levels for the product units. Again, we were able to see this data on a map view where we were able to easily contextualize our geographical distribution. And finally, we were able to have a better look at how good a solution was using our KPI analysis view with the KPIs that we've defined. Again, this is a case-to-case basis where each different customer have different needs, therefore different KPIs. Finally, we're going to go into our last stage of the demo. We're going to go into the results analysis view. So we were able to see a complete analysis of an execution. However, if we go to, for instance, forecast and simulations, we could try and make different solutions, modifying our forecast as an example of things we could do. Again, I introduced this a little bit, but what would happen if our forecast was higher? How we were able to handle that with our current data set, as well as we could go to the warehouse configuration and we could modify our availability or our different costs that we had on our product. If we try to contextualize how this would be useful on a real scenario situation, I want to go back to something that we've seen before on the outputs, on the map view. In here, we could see that from our 3 different warehouses, warehouse 1 was not used compared to warehouse 2 was used a little bit, and warehouse 3 was heavily used to cover all of our different supplies or to meet all of our demands. So let's just consider what would happen if our warehouse 3, the one in Valencia, was not able to cover all of these demands. Let's just consider in a COVID scenario, right, that there's an outbreak in Valencia and our workers are not being able to work due to COVID. What would happen if on these exceptional situations, if we were to close temporarily warehouse 3? So we're going to go back into the warehouse configuration and we would run again the data marking this warehouse 3 as unavailable. We've already done so, and we're going to explain how to do this easily, giving more value to the application. We're going to go back to the scenario manager. Okay, we're going to remove both the company plan first stage and the second stage. These ones were like midpoints of the company plan. We're going to still stick with the complete one, that one that has like the solution seen to the fullest. And we have here this alternate plan. So we've created a new scenario. We've made a copy of the previous one where we've modified this data. So we're going to add this alternative plan that we see up here, right? And we're going to put this alternate plan as the first one so we can see the data on the views. So if you go to this alternate plan, right, we've considered this scenario where we are not able to use warehouse 3. Okay, and then we've gone into the demand view, and we've also clicked on complete run to execute the model from start to finish. If we take a look a little bit at the map view, now we can see that warehouse 3 is not being used in the problem set. We're using the other different warehouses, in this case warehouse 2, to supply most of our customers. The reason why we were heavily relying on Warehouse 3 and now we're heavily relying on Warehouse 2 is mostly due to a cost. But we can easily understand this if we go to our last view in the analysis tab in the scenarios view. So if we click over here on the scenarios view, what we're gonna see here, for every single scenario that I have added to myself up here, which I have the alternative plan and the original plan that we saw before, I'm gonna do a comparison of the different KPIs that I've evaluated before for each different scenario. It's a very powerful tool that's gonna allow me to compare the first actual real scenario with these hypothetical scenarios. So we have in here, we have first a cost table. We have the different costs as rows, and we have the different costs per scenario as our columns. We have first this column for the alternative plan, and this one for the original company plan. We can see this information in this graph easily, and we can see that not using Warehouse 3 has increased the cost for our order cost, our shipment cost. The stocking cost remains the same. However, the total cost in general has increased. Not using Warehouse 3, it's gonna make the solution be higher cost because Warehouse 3 was less expensive to use compared to the other ones. We can also as well see the second KPI, where we could compare the service level agreement for the different plans. However, for our current data set, we're able to supply all of our customers with both warehouses, as well as with the 3 warehouses. So in this last stage of the demo, on this results analysis, we've added these hypothetical scenarios. We've shown how we can create these new hypothetical scenarios and use the tool to its fullest, so we could easily modify very quick and consider different real life situations. Again, at the end, we've seen this scenario comparison that allows us to make these quick decisions and comparison between these scenarios, where each company may use this tool to their fullest to analyze quick what happened in different scenarios. So, as our summary of what we've explored today, well, first of all, we're going to start with the necessity. We needed flexibility in stock levels to be able to handle this uncertainty in the demand. After we had the stock levels, we were worried about our day-to-day supply chain management. It was very important to have efficient stock management in our warehouses. To meet these problems' necessities, our proposal was an application developed with FICO Xpress Insight. So what we obtained out of this application is a user-friendly and intuitive interface that allows us to interact with the problem and the solution. And then we've obtained a clear view of the objectives and enhancements to the problem solutions. We were able to easily tell and understand all the different aspects of the problem. We were able to understand and have an in-depth look into all of them, into these objectives. As well as we also had visual analysis of any selective scenarios that we chose through these KPIs that we've defined. And that is all for this presentation. Thank you very much for attending or listening to us. Again, we have some contact information here if you want to address us. Any quick question, you want to follow up or anything, we'd be very happy to answer that. And well, thank you all for watching.